Hi learners, welcome to my YouTube channel. So today we'll do the part 2 of the standard paper. We already done part 1, you can have a look at it. So here, because this is the detailed explanation given, so it needs time, so it cannot be covered in one part. So it is given in parts. So we'll do the question number 18. In the given figure, in triangle ABC, this is the figure given. AD is parallel to, this is perpendicular to BC, and angle BAC is equal to 90 degree. If BC is 16 centimeter and DC is 4 centimeter, then you have to find the value of x. So here it's given AD is perpendicular to BC. So you can see this AD is perpendicular to, this is BC. And here BAC is BAC, means this angle is 90 degree and BC is 16 centimeter. So here DC is given as 4 centimeter. So what will be BD? Because this hole is 16. So BD is going to be this part, this BD is going to be 12 centimeter. So DC is 4 centimeter. So what we can do here, we can write here BD by AD. This BD by AD is equal to AD by this DC, since this sides are proportional. So now when you cross multiply this one, so what you can see, this is AD square is equal to BD into DC. So AD square means we got this as 12 centimeter, and this is 4 means it is 16, so this will be 12 centimeter. 12 into 4, so that is going to be 48 centimeter. So now again what we have, we want this value of this AC, that is this x part of it. So now what we can see here, that this will take this, will consider this triangle. So AD square plus DC square is equal to AC square. So AD square plus DC square is equal to AC square. So 48, we got AD square is 48. So 48 plus, we already know this is 4. This is AC is x. So this is x square. So 48 plus 16 is x square. So when you add this one, so you get 64. 64 is equal to x square. So when you square both the sides, you get x's, because this is a perfect square. So this is going to be 8x is 64 means 8. X is 8 centimeters. So this is 8. So now let us see the section B. If 4k is equal to 10 square 60 degree minus 2 cos square 30 degree minus 2 10 square 30 degree, then you have to find the value of k. So now let us start. The same thing is given over here. So now you know the values of 30, 45 and 60. That is sine, cos and tan. So 10, 60 is root 3. So this is square. So you will take root 3 square minus 2. Cosec 30 is 2. So but this is the square. So that we have got here. This is the same. Tan 30 is 1 by root 3, because this is a square, we will take the square of it. So 4k, root 3 into root 3, that is going to be just 3. Root 3 into root 3, I'll just show you. This will be root of 9. Root of 9 is 3. Now this 2 and 2 2s are 4, 4 2s are 8. And this will be here 2 into 1 by root 3, because this square is for this as well as this one. So root 3 into root 3. So this will be 2 divided by root of 9. So that is going to be, root of 9 is 3. So that will be 2 by 3. So 4k will be here. Now you will take the LCM of this one. So LCM is 3, because here is 3. So what will you get here? 9 minus 24 minus 2 by 3. So now let us take this 3 on the other side. So it will go in the numerator, because it is changing the sign. This will be minus 17. So k will be minus 17 by 12. So that is what they have asked, the value of k. Now the probability of guessing the correct answer of a certain test question is x by 12. And the probability of not guessing the correct answer is 5 by 6. Then you have to find the value of x. So probability of guessing the correct answer, that is given as x by 2. Probability of not guessing the correct answer is 5 by 6. So what will you do? They have asked, find the value of x. So what will you do? This x by 12 plus 5 by 6, that is 1. Why that is 1? Because since sum of the probabilities of an event and its complement is always 1. So this is 1. So now what will you do? You will take the LCM of this. This is going to be 12. So this will be x plus 10 by 12. That will be 1. So this There's the LCM is 12, so this will be x plus 10 divided by 12 is 1. So you will take on this 12 on this side, it will go in the numerator. 12 into 1 is going to be 12. This stays the same. So x will be 12 plus 10 will go on the other side, that is going to be minus 10. So the value of x is 2. So this is the answer for that, x is 2. Find the smallest number which is divisible by both 644 and 462. So LCM will take, in this case, we'll take the LCM of 644 and 462. So these are the factors. So this LCM is going to be 2 into this all. We have to write it here. So after multiplying this one, you get 21252. So we can say the smallest number divisible by both 644 and 462 is 21,252. So two numbers here are in the ratio 4:5 and the SCF is 11, and you have to find the LCM of these numbers. So here the ratio is given as 4:5. So what will you do? Let the two numbers be, because the ratio is given, you can write this as 4x and 5x. And HCF is given as 11 here. And you have to find the LCM. So now here what will you do? HCF is given as 11 means you can consider this x is 11. So in this place 4x, you will write here, in place of x you will put here 11. So that is going to be 44, and this 5x is going to be 5 into 11, that is going to be 55. So now we know this formula, that is LCM of A and B, that is A into B divided by SCF of AB. So this is A and this is B. So in place of this we'll write here. Now again here, this is 44 is A and this is B, and the SCF is given as 11. So here below this one we are going to write 11. So after solving this one, you get 2420 divided by 11, and when you divide it, you get 222. So the LCM of two numbers is 220. For a quadratic equation, here first let us see the question here. Find the values of k so that the quadratic equation 4x square plus kx plus 1 is equal to 0 as real and equal roots. So for the real and equal roots for the quadratic equation, this is the general form of it. So to have real and equal root, what should be the discriminant should be 0. So this stands for the discriminant, is that is b square minus 4ac is equal to 0. And here the equation has been given as 4x square plus kx plus 1. So this is A is 4, B is k, and C is 1. So that is written over here. A is 4, B is k, and C is 1. So now what will you do? We'll put these values over here. That will be k square minus 4, A is 4, C is 1 is equal to 0. So this will be k square. This whole together, that is because 4ac. So 4 4 is 16, 16 into 1, 16. So k square, if you take this on this side, that is going to be plus 16. When you square both the sides, so that is going to be k is equal to plus or minus 4. So we can write k is equal to 4 or k is equal to minus 4. If alpha and beta are the zeros of the polynomial, this is the polynomial given, then we have to find the value of alpha 4 beta cube plus alpha cube beta 4. So now let us see here. This is the polynomial given. So here what we can see, the formula for this one, alpha plus beta is equal to minus coefficient of y, because here this is given as y, divided by coefficient of y square. So coefficient of y means this is minus for this one from the formula, and coefficient of y means you have to take along with the sign, so that is going to be minus 5. So you are going to put here in the bracket, and coefficient of y square. So coefficient of y square means you cannot see anything over here, means there is 1 over here. So divided by 1. Hope this is clear. Many of them get confused over here. So minus minus becomes plus, 5 by 1, that is 5. And the alpha beta, the formula is constant term divided by coefficient of y square. So what is constant? Constant means without a variable, that is 3 along with the sign, divided by coefficient of y square, that is 1. So that is going to be 3. Now let us see, we have to find the value of the, we have to find this value. So now let us write that same thing over here. So from this one we can see this is a plus sign in between. So this is one term and this is the other term. So what we can say, we will take the common from both of them. So common what we can see, alpha cube, beta cube, this is common. So what remains in the bracket is alpha plus beta, because when you multiply this into this, you get the same as this one. When you multiply this into this, you get the same in this one. So now what you can do here, this thing, you can also write this as, because there is a multiplication sign over here, so you can also write it alpha beta cube. Alpha cube, beta cube, it will be the same of this. So why did we write this alpha beta cube? Because we know the value of this alpha beta. We don't know the value of this one separately, but we know the value. If we write in this way, we know the value of alpha beta. So this is the, so now here what we can do, alpha plus beta, also we know the value of alpha plus beta, that is 5, so we can keep as it is. So now alpha beta, that is 3, so that will be 3 cube, and alpha plus beta, that is going to be 5. So when you multiply 3 cube means it's not 9 but 3, you are going to multiply 3 times. So that is going to be 3 3 are 9, 9 3 are 27, because here also many of them just write 9, which is wrong, into 5, that is going to be 135. Now here, prove that the tangents drawn at the ends of a diameter of a circle are parallel. So at the ends of the diameter, this is a circle, at the ends of it, the tangents drawn, they are parallel. So this is the figure. This is the circle, and these are the tangents which are drawn at the ends where it is ending. They are parallel. So now given what is that? A circle with center O and diameter AB. So this is the diameter. Diameter always passes to the center of the circle. So let PQ, this is the PQ, be the tangent at point, where is it? At point A, and RS, this is the other tangent, be the tangent at point, this is the point B. And you have to prove that PQ, this is parallel to RS, this is there. So now let us start with the proof. Since PQ is a tangent at point A, we'll start first the one tangent for the PQ. So here what we can see, OA is perpendicular to PQ. So you can see here, this one, OA, this is perpendicular to PQ. So why is that? Because tangent at any point of circle is perpendicular to the radius to point of contact. And angle OAP, that is 90 degree. So you can see OAP, this one, this angle, this is going to be 90 degree. So this is equation number 1. Similarly, what we can do for the other tangent, that is RS, for this one, we can say that RS is a tangent at point B. And so what we can see here, that OB, from here, this is perpendicular to RS, tangent at any point, same thing, same points we will do. Tangent at any point of circle is perpendicular to the radius to point of contact. And here what we can see, OBS is 90 degrees. So here we can see here, this is 90 degrees. So now from what we can say here, from 1 and 2, what we can say that angle OAP is equal to 90 and OBS is equal to 90 degree. So therefore we can say angle OAP is equal to angle OBS, that is angle BAP is equal to angle ABS. And for lengths PQ and RS and transversal AB. So this is the transversal of that for this one. Angle BAP is equal to angle ABS, both because they are the both alternate angles are equal. So we can say lines are parallel, therefore PQ is parallel to RS. Now let us see the section C. If the midpoint of the line segment joining the points A, 3 and 4 and B, K and 6 is P of X and Y, and X plus Y minus 10 is equal to 0, then you have to find the value of K. So these are the A point and this is the B point given, same thing. And the equation is given as X plus Y minus 10 is equal to 0. So what we can say here, according to midpoint formula, because we have to find the value of K. So here, so P of XY, that is midpoint formula is x1 plus x2 divided by 2, and this is y1 plus y2 divided by 2. So this is going to be x1 and this is going to be y1, this will be x2 and this is going to be y2. So according to that, we can just put the values using this one. So can you see here, this is x1 plus x2 divided by 2 and this is y1 plus y2 divided by 2. So what we can write here, 3 plus this the same, and here we can write 10 by 2. So again this is the same, 10 by 2, that is going to be 5. And now here the equation is given x plus y minus 10 is equal to 0. So this in place of this x, this is whatever the points we get, this is x and y. So in place of this x, we are going to write the same. Y, we will write the same. And minus 10 is equal to 0. So now what we'll do, we'll take the LCM of this one. So this is LCM is true. So what we can write it, t plus k as it is, because here is already 2. Here will be 10. Here will be 20. And the sign the same. Divided by 2 is 0. So now if we take 2 on this side, 2 into 0, that is going to be 0. So here will be k, and after solving this one, we get minus 7. So in the next step, we can put here 0. You can put here itself 0. So that will be k minus 7 is equal to 0. So k is going to be, this goes on the other side, that is k is 7. So the point, this one, what they have said, find the value of k, that is k is. Here, this one, find the coordinates of the point which divide the line segment joining a minus 2 and 2 and b 2 and a into 4 equal parts. So what we will do here, we'll write this one, a is given and this b is given. So AB, these are the points given. So we have to divide this AB into 4 equal parts. So we can do here 1, 2, 3, and 4 parts. So now this I have named this as PQR. You can do it as you like. So the points, we don't know these points, so we can write here x1, y1, x2, y2, and x3, y3. So now what we can say, PQR, this PQR divides equally side is AB. So what we can write here, AB is equal to PQ is equal to QR is equal to PD. If this we can write it. Now if we are taking this part, and what remains is just PD. So what will be there? This is just one part, and this is going to be 1, 2, 3. So we can write this as AP is to PD, that is 1 is to 3. Then now if we are taking these two parts, so remaining is just 2, 1. So these are 1, 2, and this also will be 1, 2. So we can write it 2 is to 2, that is when we do this one, so that is going to be 1 is to 1. Now if we take this and the remaining one, this one, so this is going to be 1, 2, 3, and this is just 1, so we can write this as 3 is to 1. So now what will you do, using section formula, we can say P divides AB, P divides AB in the ratio, this P divides AB in the ratio 1 is to 3, that is 1 is to 3. So P of x1, y1, because we want this point, so that is going to be mx2 plus nx1, this is the section formula. So what will you do? This 1 is to 3, this is the value, this is m and this is n. And here we already, here we have x1, y1 and x2, y2. This is x1, y1 and this is x2, y2. So you will just put the values over here. So in place of this and m and n, this is m and n. So just put in the values. So that will be 2 minus 6 by 4, and this will be 8 plus 6 by 4. So that will be minus 4 by 4 and 14 by 4. So this will be 1, and this will be 2 2s and 2 7s. So P of x1, y1 is equal to minus 1 and 7 by 2. So now what we can say, this we got the value of P, coordinates this one of P. Now we can see Q divides AB in the ratio. What is that given? 2 is to 2. So that we can also write as 1 is to 1. So using again for that is we are going to use the midpoint formula. So again repeat the formula. So it is here. So here just put the values in that. So this will be the values m and n values, and you already know the values x2, y2. So this is 0 and 5. Now again what your P is done, Q is done. So now we will see for R. R divides AB in the ratio 3 is to 1. This is 3 is to 1. So again you are going to use the same section formula and you will solve for this one. So this is the answer. So what did we get? P, we got this one, Q, and this is R. Now here you have to prove that sec a minus 1 divided by root of sec a minus 1 divided by this sec a plus 1 plus is equal to 2 cosec a. So now this is the left hand side and this is the right hand side. So let us start with the left hand side. So what we can do here, the same thing is written here, but then what will you do? Now this is in the form of a plus b, so we consider this as a minus b. So sec a minus 1. So this is extra. So this in the numerator also it should be the same. Same for this one. It is here. This is in the form of a minus b. So this we can make it a plus b because then it will be easy. So you know the formula a minus b and a plus b, that is a square minus b square. So now this is a plus b. So same thing should be written over here because this is extra. So what we can see here in the numerator, this same thing along with this sign, this is 2 times. So we will write the sec a minus 1 and this is square of it. And this is in the form of, as I told you, this is a plus b and a minus b. So the formula is a square minus b square. So what is a square means? This is sec square minus sec square a minus 1. And same here, this is again a minus b and a plus b, that is a square minus b square. So that will be sec square a minus 1, and this is both are positive, so this we are going to write it 2 times. So now see here, this we can, when we have this one, so what we can do here, this root is for this part, numerator and denominator. So we can write here, you can also put one step over here and the square of it. So this and this goes off, so that is going to be sec a minus the root goes and also the square goes on. So here in the denominator, if you just put for this one, so this is same as here. Again here what will you do? Just this is separate, suppose. So this and this goes off, so remains is just this part. And if you take this separately, this is going to be here. So now this is the same. Now here you have the formula sec square a minus 1, that is going to be 10a because this is root of it. And this is the same. Again here sec square a minus 1, that is going to be root of 10a. So now you can see these both the places, the denominator is 10a. There's a plus sign in between. So here so you're going to add this both. So that will be sec a minus 1 plus sec a plus 1 divided by 10a. So minus 1 plus a gets cancelled. So this is going to be 2 sec a by 10a. So now this you can separate. Here what you can do, you can write here 2 sec a separately, and into this is 1 by 10a separately. So sec 2, you will keep it as it is. Sec a means sec a is 1 by cos a. So what will you do? You are going to write your cos a in the denominator, and this one you will keep it as it is, and 10 is sin a by cos a. So because we want the value, this one as 2 cosec a, so we are accordingly we have to adjust these two things by putting the formulas. So now this stays the same. So now what happens? This is the numerator and this is the denominator. So numerator stays as it is and the denominator gets flipped over. So cos a will go in the numerator and sin a will be in the denominator. So this and this gets cancelled. So what happened here? Remains is 2 by sin a. 2 by sin a means that is 2 as it is, and this is actually 1 by sin a. 1 by sin a, that is cosec a. So we can write here 2 cosec a, and that is the RHS, and that is what we have to prove. So that is proved. Now here prove that 1 by cos a minus cos a. So this the same thing. I have written it here. So here what happens? Here this is the LHS and this is the RHS. So what we can write here? LHS. Here we will take the LCM. This is 1, so we will take the LCM is cos a. So this is extra, so here also should be multiplied by cos a. Same for here, 1 into the LCM is sin a. This is extra, so this also should be multiplied by sin a. So what we get here, 1 minus this cos a 2 times, that will be cos square a. Here 1 minus this sin a 2 times means sin square a. And here what we can see, the denominator is cos a and here the denominator is sin a. Hope this step is clear. And now you know 1 minus cos square a is sin square a, because you know the first identity. I'll just do it here again. Sin square a plus cos square a is equal to 1. So what we can do here, if we are taking here sin square a is equal to 1 is already on the right hand side, is plus cos square a. If it goes to the other side, that is going to be minus cos square a. So can you see here 1 minus cos square a? So what will be that? That is going to be sin square a. So this will be sin square a. This cos a as it is. Again here 1 minus sin square a means again the same identity. You can just rearrange and see, you get cos square a. divided by sin A. So now what you can see here, from here, this cos A and this is cos square A means here only one cos square A means cos A into cos A, right? So one goes off means remains is cos A. Again from here and this one, this is sin square A means sin A into sin A. So one gets cut from here, so remains is sin A. So what we can write here, sin A cos A in the numerator. So this is, we can say, equation number 1. So now in the we'll take the RHS. RHS is 1 by 10A plus cot A. So we can write this one as it is. 10A we can write, for this 10A we can write sin A by cos A. And for cot A, we can write this one as cot is cos by sin. Yes, cos A by sin A. So now this is the numerator. This is the denominator. Now you can see here the LCM we can put here. That is going to be, we have to put here extra sin A. So this also should be sin A. Here we are going to put extra cos A. So here also should be cos A. So that is going to be sin square A, and this is going to be cos square A. And of course the LCM is sin A, or we can add cos A sin A. And the numerator stays as it is. So now what we can do, this one will keep as it is. Now you know the first identity, sin square A plus cos square A, that is 1. So this is 1 for that. And the denominator stays as it is. So this is the numerator, this is the denominator again. So what happens here, numerator stays as it is, the denominator gets flip over. So this cos A sin A goes in the numerator. So, or we can also write that sin A cos A. So this is equation number 2. Why did we write that instead of writing cos A sin A? Because 4 into 5 also is 20 and 5 into 4 also is 20 in multiplication. We can write other ways. So this is 1 and this is second, both are same. So what we can say, from 1 into LH is equal to RHS, so that is proved. So by this one we have completed today's work. Do like and subscribe to my channel so you get the notification of other parts. Thank you.